So here's our third example. The matrix R cosine theta sine theta minus sine theta cosine theta represents a rotation. Show that the square of that matrix and cube of that matrix are matrices that correspond to rotations of 2 theta and 3 theta respectively. So let's first work on the square of the rotation matrix. R matrix squared. So we have cosine theta, first element, sine theta, first row, second column, minus sine theta, second row, first column, cosine theta, second row, second column, and we're going to multiply it with itself. So the same matrix, cosine theta, sine theta, minus sine theta, cosine theta. Let's start working on this product. First, I have cosine square theta, and then I have minus sine square theta. So cosine square theta minus sine square theta. Then I have cosine theta sine theta plus sine theta cosine theta. So that's going to give me twice cosine theta sine theta. And then I have minus sine theta cosine theta minus sine theta cosine theta, which will give me minus 2 sine theta cosine theta. And then I have minus sine square plus cosine square theta minus sine square theta plus cosine square theta. So let's see what this is. Now you can recognize cosine 2 theta is the half angle formula is cosine square theta minus sine square theta, and for sine 2 theta the half angle formula is 2 sine theta cosine theta this is what we know from trigonometry. So if I recall these results from trigonometry, then I see that the square of the rotation matrix R square is the first element, cosine square minus sine square, is cosine 2 theta. The second element is 2 cosine sine, that is sine 2 theta. The third element, minus 2 sine cosine, is minus sine 2 theta. The fourth element, minus cosine square minus sine square, that is cosine 2 theta. So that's my answer for R square. And I can see that cosine theta has been replaced with cosine 2 theta, sine theta with sine 2 theta, minus sine theta with minus sine 2 theta, and cosine theta with cosine 2 theta. Therefore, I conclude that R square is representing the rotation by an angle 2 theta as suggested by the problem statement. Now let's work on the cube of the rotation matrix, R cube. So I will be multiplying the R matrix, rotation matrix, cosine theta, sine theta minus sine theta cosine theta with the square, which is cosine 2 theta sine 2 theta minus sine 2 theta cosine 2 theta. So let's see what this gives us. We have cosine theta multiplied with cosine 2 theta. And added to this, we have cosine theta multiplied with sine 2 theta and sine theta multiplied with cosine 2 theta. So first row, second column. So first row, first column is what we have to do first. Cosine theta cosine 2 theta minus sine theta sine 2 theta. That's the first element. Sine theta sine 2 theta. Then cosine theta sine 2 theta sine theta cosine 2 theta. So we have cosine theta sine 2 theta plus sine theta cosine 2 theta. Then minus sine cosine 2 theta plus cosine minus sine 2 theta. So we have minus sine theta cosine 2 theta and then minus cosine theta. So minus sine cosine minus sine 2 theta times cosine theta. And the last element is minus sine theta sine 2 theta. And then we have plus cosine theta cosine 2 theta. This is our rotation matrix cube. Now let's recall cosine 3 theta. That is cosine theta plus 2 theta. This is cosine theta addition formula, cosine 2 theta minus sine theta sine 2 theta. And how would you write sine 3 theta? Sine theta plus 2 theta is sine theta cosine 2 theta plus cosine theta sine 2 theta. So we recall this trigonometric identity. So with that, we can use this identity to write the rotation matrix cube. This is equal to the first term, cosine theta cosine 2 theta minus sine theta sine 2 theta. That corresponds to cosine 3 theta. The second term, cosine theta sine 2 theta plus sine theta cosine 2 theta. That corresponds to sine 3 theta. And then we have in minus parentheses sine theta cosine 2 theta plus cosine theta sine 2 theta, which is minus sine 3 theta. And the last term here, cosine theta cosine 2 theta minus sine theta sine 2 theta, that is cosine 3 theta. Okay, so let me write this, cosine 3 theta. And that's my answer for the cube of the rotation matrix, where I recognize it to be equivalent to the rotation matrix with an angle 3 theta instead of theta. So this corresponds to rotation by an angle of 3 theta, as suggested by the problem statement. So we were supposed to show that given the rotation matrix, its square represents the rotation by an angle 2 theta, cube represents rotation by an angle 3 theta. When we performed the matrix multiplication, we have to know the half angle formulas from trigonometry. Cosine 2 theta is cosine square minus sine square. Sine 2 theta is 2 sine cosine of the angle theta. Utilizing that, we can figure out that it's the rotation by angle 2 theta, and addition formulas cosine theta plus cosine a plus b is cosine a cosine b minus sine a sine b, and sine a plus b is sine a cosine b plus cosine a sine b. So utilizing this, we obtain the 3 theta formulas, and we can see that that's exactly what we obtain in the multiplication of r square with the R matrix, and that corresponds to a rotation of an angle of 3 theta.